Good morning, students. All we'll discuss today real nature of matter and radiation. So, real nature of matter and radiation totally 6 marks. Entire chapter totally how many marks will come means 6 marks. So, in this 6 marks, one mark question will come from this, and 5 marks problem will come from this. Totally 6 marks, one mark question and one 5 marks problem will come this from this chapter. One by one, all are the 1 mark questions we will discuss. See the first question. What is meant by electron emission? The process of emission of electrons from a metal surface when suitable energy falls on it. There is a metal surface. On that metal surface, when suitable energy falls, electrons will come from that metal surface. That phenomenon is called as the electron emission. The process of emission of electrons from a metal surface when suitable energy falls on it. That will be called as the electron emission. Electron emission will be is of 3 types. First one will be thermionic emission. Another one will be field emission. Another one will be photoelectric emission. And next, what is meant by second question? Thermionic emission. The process of emission of free electrons from a metal surface by heating. By heating any metal surface, from that metal surface, if electrons are came, then so what we are doing here by heating that metal surface, if electrons are came, then that will be called as the thermionic emission. Next, second one will be, third one will be what is field emission? By creating strong electric field on a metal surface, if we remove from that metal surface, then that will be called as the field emission. So see here, third question, what is field emission? The process of emission of electrons, the process of emission of electrons from a metal surface when strong electric field is applied on it, that is called as the field emission. So when strong electric field is applied on a metal surface, if electrons came from the metal surface, then that will be called as the field emission. See the fourth question. What is photoelectric emission? The process of emission of electrons from a metal surface. So this first line will be common, the process of emission of electrons from a metal surface when light of suitable frequency, falls on it, that will be called as the field emission. That will be called as the photoelectric emission. Next, see the fifth question. What is photoelectric effect? Photo means what? Light. Electric means electrons. When a light incident on some metal surfaces, electrons will come from the metal surfaces. That effect will be called as the photoelectric effect. So what is the definition? When light of suitable frequency falls on some metals, what are that metals? Sodium, potassium, lithium, like that metals. Alkali earth metals, if light incident, free electrons are coming from that. This phenomenon is called as the photoelectric effect. Next, define photoelectric work function, or simply what is meant by work function. Some minimum energy is required to remove the electrons from the metal surface. That minimum energy will be called as the work function. The minimum energy required to just liberate an electron from a metal surface, that will be called as the work function. So work function definition, minimum energy required to just liberate an electron from metal surface. That will be called work function. Next, define threshold frequency. What is threshold frequency? The minimum frequency of incident radiation below which photoelectrons does not takes place. So a metal will have some frequency, some threshold frequency. If the incident frequency is less than that, electrons won't come from that metal surface. That frequency will be called as the threshold frequency. So the minimum frequency of incident radiation below which photoelectric effect does not take place, that will be called as the threshold frequency. Next, what is stopping potential? You see here in the Millikan's experiment, the negative potential applied to the anode. When light incident on the metal surface, electrons will come. Those electrons, see here how it will be there means, here this will be tube. Like this. Here cathode will be there. When light incident on it, when light incident on the cathode in this way, from that electrons will come from this. Okay, so like this, in this format, electrons will come from this. Okay, here anode will be there. This will be entire tube. Okay. Now what will happen? See, if you give negative potential to this anode, then it will repel the electrons. So they won't reach to, though they are coming from, this is light. When light incident on it, electrons are coming. But those electrons are not reaching to anode because we are giving negative potential to the anode. That negative potential will be called as the stopping potential. So the minimum negative potential applied to the anode to just stop the photocurrent. Electrons are stopping means photocurrent is stopping. That will be called as the stopping potential or cutoff potential. Next, what are matter waves or de Broglie wavelengths? Waves, the waves associated with the material particles in motion. When material particles are in motion, the waves associated with the matter wave, material particles, when they are in motion, will be called as the matter waves. See the 10th question. What is de Broglie wavelength? What is de Broglie wavelength? The length of de Broglie waves, that will be called as the de Broglie wavelength. The length of de Broglie waves will be called as the de Broglie wavelength. See the 11th question. Write the expression for de Broglie wavelength of a particle of mass m having speed v. De Broglie wavelength formula, lambda is equal to h by p. So h by p means momentum. So this value will be mv. This is the h. So here, what is h here? Planck's constant. Write down where h is equal to Planck's constant. M is equal to mass of particle. Already they give V is equal to velocity of particle. Okay. Formula for the D bro. Just one more question only. If you write this is enough. So no need for the terms explanation also. Lambda is equal to H by P, H by MV. You wrote this one. So that will be more than enough for this. This one. So lambda is equal to H by P. H by MV will be the answer for it. Next, see the 2 marks questions. Mention any 2 types of electron emission. Electron emission will be 3 types. What are that? Thermionic emission means heating the metal, we are producing electrons. Field emission means by applying electric field, we are creating the electron, producing the electrons by sending incidenting light on the metal surface. If we produce electrons, then it will be called photoelectric emission. Write any of these 2. Next, write Einstein's photoelectric equation and explain the terms. So Einstein's photoelectric equation, what is that? H nu is equal to H nu naught plus Ke maximum. This is Einstein's photoelectric equation. Here, what are the terms involved in this means where H value will be Planck's constant. Nu is equal to incident frequency. Nu naught is equal to threshold frequency. So and Ke maximum is equal to maximum Ke of electron. 3-4 different forms are there. You just write the basic form, that is enough. So these are the 1 mark and 2 marks questions. Mainly you concentrate on the 1 marks because in this chapter, 1 mark question and 1 5 marks question will come in this. That's why you concentrate on this problems and 1 mark questions. Problem C, just 2 models are there. One by one we will discuss that models. First problem, the work function of CCM is 2.14 electron volt. So here W value is equal to W, how much they are giving, 2.14 electron volt. So stop Indra. Okay. Then recording. So work function here, they gave W is equal to 2.14 2.14 electron volt, 2.14 into 1.6 into 10 power minus 19. If you multiply that to this value, 3.424 into 10 power minus 19 joules. This is work function. And work function given when light of frequency. So new value will be equal to 6 into 10 power 14 H. And then photoelectrons are coming. Then what is the energy of the incident photons? And how to do this one? See, incident energy formula E is equal to H nu. H value they gave 6.63 into 10 power minus 34. New value they gave 6 into 10 power 14. If we calculate this value 39.78 into 10 power minus 20 will be there. So this is 3.978 into 10 power minus 19 joules. This is the energy of the incident. Next, maximum kinetic energy is how much? That is the question. So here, according to Einstein's photoelectric equation, E is equal to W plus Ke maximum. Here already E value we got. How much we got? 3.978 into 10 power minus 19. W value will be 3.424 into 10 power minus 19 plus Ke maximum. Then Ke maximum value will be Ke max is equal to 3.978 minus 3.424 into 10 power minus 19. We can take common. So this value 0.55 into 10 power minus 19 joules. This is the kinetic energy. This one they are asking. So this one they are asking what is the kinetic energy, and one more thing they are asking what is the energy of the incident photon. They gave frequency. From the frequency we are calculating that energy. So that value 3.98 into 978 into 10 power minus 19 joules. Okay. Next, see the second problem. What they are asking. Light of frequency 8.41 into 10 power 14 Hz. So, is incident on a metal surface. Incident frequency value will be 8.41 into 10 power 14 Hz. That is incident frequency. Electrons are coming from it with a velocity of 7.5 into 10 power 5 meter per second. Calculate the threshold frequency and also find the work function in electron volt. So from Einstein's photoelectric equation, what is the formula? H nu is equal to W plus Ke maximum or half mv square. Here H value they gave 6.625 into 10 power minus 34. New value 8.41 into 10 power 14 is equal to W value. First we will calculate W, right? H nu W as 6.625 into 10 power minus 34 plus half into 9.1 into 10 power minus 13. Velocity 7.5 into 10 power 5 meter per second. If we calculate this, finally, what we have to calculate here? H value, this is here nu naught. This nu naught value we have to calculate here. Here, okay. Here we have to write here nu naught half into 9.1 into 10 power minus 31, 0.5 into 10 power 5 whole square. If we calculate, finally we will get nu naught value as 4.546 into 10 power 14 H. Okay, that is nu naught value. And work function they are asking, W is equal to H nu naught 6.625 into 10 power minus 34 into 4 point, multiply this 4.546 into 10 power 14, 6.625 into 4.546. Multiply these two, how much? Approximately around this value 30.11 into 10 power minus 24 joules. They are asking work function in electron volt. So that's why we will calculate that. W is equal to 30.11 into 10 power minus 24 divided by 1.6 into 10 power minus 19. So 18.81 into here 20. It's 20. So this is 20 means 18.81 into 10 power minus 1, 1.88 electron volt. So that is the work function. So what we have to find here, we have to find work function value in electron volt, that is second one. And the next, this one we have to calculate here. And one more, what is the threshold frequency we have to calculate. Threshold frequency value will be 4.546 into 10 power 14 H. Last problem C. Calculate the de Broglie wavelength associated with an electron moving with a speed of 2 into 10 power 6 meter per second. So what are the given values? You see, there is an electron. It is moving with a velocity of 2 into 10 power 6 meter per second. Find the de Broglie wavelength of the electron. Lambda is equal to h by mv. H value 6.625 into 10 power minus 34 divided by 9.11 into 10 power minus 31, velocity 2 into 10 power minus 6. If you calculate, finally this value 3.636 into 10 power minus 10 will comes. Means this is 3.636 angstrom unit. Okay. So this is the de Broglie wavelength of that electron. These three models are enough. You prepare these three models and prepare that 1 marks questions. So thoroughly you can able to answer any question from this chapter. Like that it will come. Okay, we'll start the session now.